Okay, so for today, we're going to go ahead and talk about the second type of special right triangle that we have here in Chapter 8. The special right triangle that we're going to deal with today is the 30, 60, 90 right triangle. So right here we've got how we're going to derive the formulas that we were going to use for this 30, 60, 90 triangles. So we've got an equilateral triangle over here with A, B, and C, and all sides are going to go ahead and just give us an easy number here, 2 inches. What is the measure of each acute angle? So if we really think about this, if we recall from last semester, the inside angles of a triangle add up to 180. If there's 3 equal angles, 180 divided by 3 is going to have to be 60 degrees. This next step, part B, asks us to draw AD, which is a perpendicular bisector of BC. So if we draw in AD, the perpendicular bisector of BC, what's the length of BD and CD? So if this is a perpendicular bisector, remember bisect means to create 2 equal parts. So if this original length was 2, this is going to go ahead and now be 1. So both of those are now going to be 1. What does AD do to angle A? AD now, since it is a perpendicular bisector, it does bisect this angle up here from going from 60. Since it's bisecting, now that the measure of BAD and DAC are going to be 30 degrees. And this was once again that it bisects the angle. So now it asks us to find the length of AD and leave your answer as a simplified radical. So if we recall from the last video from last weekend in the Pythagorean theorem, this is now a right triangle, and we're able to use the Pythagorean theorem of, once again, a squared plus b squared equal to c squared to find out the length of what in this case would be b. We're given the hypotenuse and we're given one of the legs. So if we remember, the Pythagorean theorem is leg squared plus leg squared equals hypotenuse squared. So we've got 1 squared plus b squared equals 2 squared. 1 squared is 1 plus b squared, 2 squared is 4. From here we're going to continue on. We're going to subtract that 1 over, and that gives us that b squared equals 3. Remember that square roots and squares are inverses of each other, so we're going to go ahead and get b by itself, and b is going to be equal to the square root of 3. The square root of 3 is the most simplified radical form that we can do, so we have now found that b is going to be the square root of 3. To help us out here, we're going to have some shortcuts and just rules that we're going to follow. In a 30, 60, 90 right triangle, there's going to be a short leg, a long leg, and a hypotenuse. The hypotenuse is always across from the right angle, so this is the hypotenuse. How do you know which is the short leg and which is the long leg? We're able to figure this out by looking at what the angles are. If this was a 45, 45, 90 triangle, both of these legs will be the same length because both of these angles are the same. But now, since they're not the same, they're not equal, the shortest leg is going to be across from the 30-degree angle. So this is the 30-degree angle, so that would make this the short leg, which remains, we've taken care of the short leg, we've taken care of the hypotenuse, now this is the longer leg. And remember, to keep things simple, we're just going to call this hypotenuse h. So the formulas for finding the sides of a 30, 60, 90 right triangle are as followed. For h, h is going to be found by doing the short leg times 2, or the 2 times the short leg, whichever you prefer. Still simplifies to the same thing, but it'll be 2 times as long as the shorter leg. For the longer leg, once again, we're going to work with the shorter leg, and it's going to be short leg times radical 3, or radical 3 times the shorter leg. Ways to find shorter leg is if you have h equals 2 times SL, all you do is divide by 2, and the shorter leg would be h over 2. If you're working with the long leg and you're trying to find the short leg, once again, we've got long leg equals short leg times radical 3. Here we'd have to divide by radical 3 and rationalize. So the short leg would be longer leg over radical 3, and we will need to rationalize at this point, where we would have square root of 3 times the longer leg over 3. But we'll get into that more as we continue. So let's just jump into a couple examples here. They tell us to find x and y. Since we have identified that this is the 30-degree angle, we're going to go ahead and label that 6 is the short leg, y is the long leg, and x is the hypotenuse. And we're just going to refer up here to our formulas, and we're going to be, since we're going to start off with an easy one, they give us the short leg, so we fall into both formulas. If we're looking for the hypotenuse equals short leg times 2. So the short leg here was 6, now we're just going to multiply it by 2, and the hypotenuse is 12. The hypotenuse was referring to x, so x is going to be 12. Now let's take a look at the long leg. The long leg's formula is long leg times radical 3, or long leg equals short leg times radical 3. So we have long leg equals short leg, which we know is 6, times radical 3, and there we have our answer for y. So the longer leg is going to be 6 radical 3. Moving on to this next example, example number 2, we have a 60-degree angle here, which makes 12 the long leg, and makes x the short leg, and y still the hypotenuse. Since we were given a longer leg now, we're going to have to use one of these formulas to get to where we need to go. So when we look at the long leg equals short leg times radical 3. So now that we have the long leg, we're going to have 12 equals short leg times radical 3. To solve for short leg, we're going to divide by radical 3 on both sides. I'm going to turn this around just so I have more room to work. But we've got short leg equals 12 over radical 3. We're going to rationalize and multiply by radical 3 over radical 3. And that equals 12 radical 3. Radical 3 times radical 3 is the square root of 9, and the square root of 9 is 3. We can simplify here. 12 over 3 is just 4 radical 3. So now that is referring to the short leg, so that in our case was x, and that's going to be 4 radical 3. Now that we have the short leg, we can use the hypotenuse formula, which is just a short leg times 2. So h equals short leg, which is now 4 radical 3 times 2, and 4 times 2 is 8, which makes the hypotenuse 8 radical 3, or y equals 8 radical 3. So that's the two formulas that we're going to need to use, and you can use these two subsetted formulas when you solve for short leg if you're not given the short leg. We have a couple more examples here on this next page, and then any questions we have, we can take them in the start of class on Tuesday. We will also discuss 30, 60, 90 in a little bit more depth when we get to Tuesday. So now we're looking at another example here, and they ask us to find the value of d in simple radical form. D is across from the 30-degree angle, which allows that to be known as the short leg, and now we know 5 is the long leg. To help us out here, and to help you out on your homework, you might as well just put both of those formulas at the top of your paper, where we know that h equals the short leg times 2, and the long leg equals short leg times radical 3. And when it comes to quiz time and test time, you're going to want to write these formulas as soon as you get your test, just to help you out. So they ask us to find the value of d. D is the short leg. They gave us the long leg, so we're going to use long leg equals short leg times radical 3. So long leg, which is 5, equals short leg times radical 3. Get short leg by itself, we're going to divide by radical 3. And then we have short leg equals 5 over the square root of 3. We're going to rationalize because we don't like denominators with radicals. And this equals 5 times radical 3. Once again, radical 3 times radical 3 is the square root of 9. The square root of 9 is 3. And that is the value of d. Now it asks for the value of f, which is the hypotenuse. So the hypotenuse equals short leg times 2. The short leg we just found is 5 radical 3 over 3. So if we have 5 radical 3 over 3, which is the short leg, times 2, that'll give us our hypotenuse. 5 times 2 is 10 radical 3 over 3. And there is our answer for hypotenuse. 2 more examples here, and then we'll be done with the video for today. An artisan makes pendants in the shape of equilateral triangles. The height of each pendant is 18 millimeters. What is the length S of each side of the pendant to the nearest tenth of a millimeter? So since it asks for the nearest tenth of the millimeter, we're not going to go ahead and have our answers end in a radical. In the picture over here, I'll draw it just so it's a little clearer so everybody can see it. These are right triangles, which means this was originally 60 and this was cut in half, making it 30, and this is 18. I'm going to go ahead and draw the triangle so we can see it just a little bit clearer, because you guys know I have small handwriting. If this is 60, that would make 18 the long leg. This would make this the short leg, and this would make this the hypotenuse. So since we were given long leg as 18, we're going to go ahead and say 18 equals short leg times radical 3. So now we're trying to find the short leg. We're going to have to divide by radical 3 to get short leg by itself. Once again, I'm just going to flip this around just because it gives me more space to work. That gives us that a short leg equals 18 over radical 3. Once again, we're going to rationalize. 18 times radical 3 is 18 radical 3 times radical 3. Once again, square root of 9. The square root of 9 is 3. We're not done yet because we still need to simplify here. 18 over 3 just simplifies to 6, so we're going to have 6 square root of 3, and that equals our short leg. So now that we have our short leg taken care of, we're going to still have to find our hypotenuse, and our hypotenuse equals short leg times 2. In this case, h equals 6 radical 3 times 2, and 6 times 2 is 12, so h equals 12 radical 3. And these are the two sides, and since they ask for to the nearest tenth of a millimeter, we're going to go ahead and just pull out our calculators and see what that is. So we've got 6 times the square root of 3, so the square root of 3 is 1.73, and we're going to multiply that by 6, and to the nearest tenth of a millimeter makes that 10.4, equals the short leg. Once again, we're going to go back to the square root of 3, which once again is 1.732, and we're going to multiply that by 12, and we get 20.78, and to the nearest tenth, that's going to be 20.8 millimeters. Make sure that we're being very aware of what the directions in the problem ask us to do when we come to tests, quizzes, and homework. Because during a test, if you give me this answer right here, you're going to be docked half a point. Same thing here, you're going to be docked half a point. So make sure you're very cognizant of what things are asking you to do. The next question is, suppose the sides of the pendants were 18 millimeters long instead of the hypotenuse. Or so suppose the sides were 18, so that would make the hypotenuse 18. If the hypotenuse was 18, we can go back to our formula. And 18 equals short leg times 2. This is pretty simple. Do some simple algebra here. Short leg is 18 divided by 2, which means short leg equals 9. So the short leg equals 9. So now that we can figure out the long leg equals short leg times radical 3. So long leg equals short leg, which we just found was 9, times radical 3. And there's our answer, but once again, to the nearest tenth of a millimeter, we're going to go ahead and figure that out. So we're going to go ahead and pull out our calculators again. Once again, we're going to go take the square root of 3. And we're actually going to do that, right? And we're going to clear that. We're going to take the square root of 3, which is 1.72, and we're going to multiply that by 9 in this case. and to the nearest millimeter, 15.58 goes to 15.6 millimeters. And there is our answer. So the biggest thing we need to take from this video is basically these two formulas that we had. These two formulas will get us any answer on any test when we're dealing with 30, 60, 90 triangles. Hope everybody enjoys their 4-day weekend. I'll see you on Tuesday. Any questions, any questions at all that we have, make sure we get them asked, and I will answer them on Tuesday in class. See you guys on Tuesday.